Hi, welcome to Lecture 16, Balancing Chemical Equations. The systematic approach to balancing equations consists of several steps. The first step is to write the equation with the reactants and the products. Reactants are on the left side, products are on the right side. Here we have propane plus oxygen equals carbon dioxide plus water. The second step is to find one atom that occurs only in one substance on both sides. I selected carbon, C. So there's one carbon on the left, one carbon on the right. We find the coefficients to balance this atom. So we have one carbon 3 in propane. 3 times 1 is 3. That's on the left. We have 3 carbons. If we look on the right, we add a 3 coefficient, and now we also have 3 carbons for 3 CO2 molecules. Step 4, we find another unbalanced atom that occurs only in one substance on both sides. Here I've selected hydrogen. We have 8 hydrogens on the left side, but only 2 hydrogens on the right. So we find the coefficients to balance this atom of hydrogen, and we put a 4 in front of the H2O. Now we have 8 hydrogens on the left, 8 hydrogens on the right. We repeat steps 4 through 5 until all the atoms are balanced. Here we have 3 carbons on the left, 8 hydrogens on the left, 10 oxygens on the left. We also have 3 carbons on the right, 6 oxygens on the right, 8 hydrogens on the right, plus another 4 oxygens. 4 plus 6 is 10 for the oxygens, which balances because we have 5 O2s on the left side. So we reduce the coefficients to the smallest whole number. Since we have one propane molecule, we cannot reduce it any further. So the coefficients remain 1, 5, 3, and 4. So then we check the equation to make sure it's balanced. 1 propane molecule plus 5 oxygen molecules equals 3 carbon dioxide molecules plus 4 water molecules. We have 3 carbons on the left, 3 carbons on the right. We have 8 hydrogens on the left. We have 8 hydrogens on the right. We have 10 oxygens on the left, and we have 10 oxygens on the right. So that's a systematic approach to balancing chemical equations. Now let's look at some examples. But before we do that, we got to get into the symbols used to indicate physical states. For general purposes, there are 4 states of matter. There's the gas state, the liquid state, the solid state, and the aqueous or water state. For this lecture, we'll just stick to those 4 states. So our first example is the unbalanced equation of methane plus oxygen equals carbon dioxide plus water. They are all gases. That's what the little g in parentheses means. So now we need to balance this equation. So I start with carbon. We have 1 carbon on the left. We have 1 carbon on the right. It's already balanced. So then I look at the oxygens. Well, if I add a 2 coefficient to the oxygen, and then I add a 2 coefficient to the water, we now have 4 oxygens on the left, 4 oxygens on the right. Finally, I look at the hydrogens. We have 4 hydrogens on the left, and if I put a 2 in front of H2O, I then have 4 hydrogens on the right. So now I check to make sure the equation's balanced. The left side has 1 carbon, 4 hydrogens, 4 oxygens. The right side has 1 carbon, 4 hydrogens, and 4 oxygens. The equation is balanced. Another example is iron plus oxygen equal iron oxide. To balance this equation, I first look at the iron. I have 2 irons on the left. I have 2 irons on the right. I then look at the oxygen. If I put a 3 coefficient in front of the oxygen, I have 6 oxygens on the left. If I put a 2 coefficient in front of iron oxide, I now have 6 oxygens on the right. In order to balance this out, I now have 4 irons on the left, so I need to have 4 irons on the right, so I need to have 4 irons on the left. To do that, I change the coefficient on the front of the iron on the left side to 4. I now have 4 irons on the left, 4 irons on the right. I have 6 oxygens on the left, and I have 6 oxygens on the right. The equation is balanced. Another example is ethane, plus oxygen equals carbon dioxide plus water. To balance this equation, I start with the carbons. I balance them so there's 2 carbons on each side. I then look at the oxygen, and I balance the oxygen so there are 6 oxygens on each side. I then look at the hydrogens, and I balance them so there are 4 hydrogens on each side. And then I look at the equation, its reduced form, since you cannot reduce one ethane molecule any lower, and I check it. There are 2 carbons on the left, 2 carbons on the right. There are 4 hydrogens on the left, there are 4 hydrogens on the right. There are 6 oxygens on the left, and there's 6 oxygens on the right. The equation is balanced. Pretty simple. Here, this is a little bit trickier. I recommend you try solving this one on your own and then coming back and checking your answer. That'll show that you understand the concept. Here we have aluminum plus hydrogen chloride equals aluminum trichloride plus hydrogen gas. So we have 1 aluminum on both sides starting with the equation, so it's already balanced. We then have to look at the chlorides. In order to get the 3 chlorides that we have on the right, we add a 3 in front of the HCl. We now have 3 chlorides on the left. Now we had to double the hydrogens on the left to equal the hydrogens on the right. The reason for that is we had 3 hydrogens on the left and only 1 hydrogen gas molecule on the right. So in order to balance that, we need 6 hydrogens on the left, 6 hydrogens on the right. So we changed the coefficients to 6 HCl and 3 H2. We then look at the chlorides again. We have 6 chlorides on the right, so we have to add a 2 coefficient in front of the aluminum trichloride. Now we have 6 chlorides on the left and the right. We then go to look at the aluminum. Since we added 2 aluminums to the right of the equation, we have to go back and add 2 aluminums to the right and 2 aluminums to the left. So we balance the aluminums out. We then check the equation, and we find we have 2 aluminums on both sides, 6 hydrogens on both sides, and 6 chlorides on both sides. The equation is balanced. Here in our final example, we take iodine plus chlorine plus water to equal iodic acid plus hydrochloric acid. Iodides we balance to have 2 iodides on both sides. Chlorines we balance, so we have 2 chlorines on each side. We then balance the oxygens, so we have 6 oxygens on both sides. We then go back and we have to adjust the hydrogens to account for the 12 hydrogens on the left side of the equation. We do this by adding 10 hydrogen chlorides. And then we go ahead and we go back and we adjust our chlorides on the left side of the equation. We have 5 chlorides times 2, which is 10 chlorides total on the left side, and we have 10 hydrogen chlorides or 10 chlorides on the right. The equation is now balanced with 2 iodides on both sides, 10 chlorines on both sides, 12 hydrogens on both sides, and 6 oxygens on both sides.